Hi there. This video lesson covers writing Lewis structures. And Lewis structures are essentially pictures or drawings of molecules. So the last video lesson you learned how to write the formulas and the names of molecular compounds or covalent compounds. In this video lesson, you're going to learn how to draw the structure, to draw a picture of what that molecule actually looks like. And it comes down to these 5 steps here in the notes. You'll want to print those out. And for this video lesson, what I'm going to do is I'm just going to jump right in and we're going to start doing examples. And we're going to work through these 5 steps with these examples here at the bottom. So the first example is chlorine. Let's see if I can get this thing to work here. Okay, chlorine, Cl2. If I look at the periodic table, actually, before I do that, step 1 is find the total number of valence electrons in the molecule. And the way we do that is the 1 through 8 pattern. The 1, 2, skip a few, 3, 4, 5, 6, 7, 8 pattern on the periodic table. So all these have 1, all these have 2, skip a few, 3, 4, 5, 6, 7. So we see that chlorine is in the 7 valence electron column. So chlorine has 7, but we have 2 chlorines. So let's see here. 2 chlorines. Okay, let's try that again. Chlorine, Cl2. We got 2 chlorines, and each chlorine has 7. So 7 times 2, we have 14 total valence electrons to work with. So what I'm going to do is I'm going to do step 2, which is draw the symbols of the elements. Some tips here: if there's just one of something, typically it goes in the middle. Carbon always likes to go in the middle. Hydrogen always likes to go on the outside. Other than that, it's a little bit of trial and error and just kind of getting used to how to do this. As you do more of them, you'll get better at them. So draw the symbols of the elements. And I have 2 chlorines, so I'm going to draw 2 Cls. Now, step 3 is draw lines to form single bonds connecting the atoms. There's my single bond. Now that one line equals 2 shared electrons. So the line represents the fact that this chlorine and this chlorine are sharing those 2 electrons. So that's step 3. Step 4, I draw the remaining dots. So I got to draw dots to make everybody happy. Well, almost all atoms want 8 valence electrons. They're happy when they have 8. So chlorine, right now it has 2 from the line. So to get 8, it needs 6 more. So I'm going to draw 6 dots. So now this chlorine on the left has 2, 4, 6, 8. It's happy. This chlorine over here isn't happy. So I'm going to draw 6 dots on this. So if we look, both chlorines are happy. The left chlorine has 2, 4, 6, 8. The right chlorine has 2, 4, 6, 8. Remember, the 2 in the middle are being shared, so you can count them for either one. So we did step 4, we made everybody happy by giving them dots so that they have 8. Now the one exception to that is hydrogen. Hydrogen only wants 2, but everybody else wants 8. And it doesn't matter how many they start with. Chlorine started with 7, but its goal is to get 8. And you want to make everybody happy, so you want to get their goal. So step 5. Check to see how many electrons you use. So basically what we're doing here is we are going to compare the number with the drawing. Does our drawing have 14 valence electrons? 2, 4, 6, 8, 10, 12, 14. So if those two things match, you're done. So right there, that is the Lewis structure, or the structural formula. Another way of saying that is a structural formula for Cl2. That's what a Cl2 molecule looks like. So let's do another example. Next one is CH4. Again, we're going to work through these steps. So CH4. First step is to find total valence electrons. Carbon, if we look at the periodic table, is 1, 2, skip a few, 3, 4. So carbon gets 4 dots. Hydrogen is in the first column, so it gets just 1 dot. So let's see, carbon, we said, got 4. So again, carbon has 4. Hydrogen has 1 dot, but there's 4 hydrogens, so it's 1 times 4. So 1 times 4 is 4, plus another 4 is 8. So we have a total of 8 valence electrons to work with. So that's step 1. Step 2, draw the symbols of the elements. Like I said, carbon likes to be in the middle, and hydrogen likes to be on the outside. And since there's 4 of them, I'm going to evenly kind of distribute them around here. These molecules, as much as possible, want to be kind of symmetrical and balanced. You're not going to have all 4 H's hanging out on one side. They kind of want to spread out. So that's step 2. I draw the symbols. Step 3, I draw single lines connecting the outer atoms to the central atom. Then step 4 says draw the remaining dots so everyone is happy. Well, let's look here. If you remember, carbon, just like most elements, wants 8, and a line equals 2. So this carbon has 2, 4, 6, 8. The carbon is actually happy. You don't have to add any dots. The carbon is happy. And the hydrogens are also happy because hydrogen is happy with 2. It's the exception. And the line equals 2. So this hydrogen's happy with its 2. Same here, same here, same here. So everybody is happy. The next step is step 5. Check to see how many electrons you used and compare it to the number you started with. So we have 8 to work with, and we've got to make sure that our picture matches that number. If you remember, each line equals 2. So 2, 4, 6, 8. Total valence electrons in the picture is 8, and it checks out. So that is the Lewis structure for CH4. Next example, CO2. This one's a little bit trickier. Okay. What did I say it was? CO2. Total valence electrons for CO2. Carbon, if you look it up on the periodic table, is 4, just like we said. Oxygen is 6, but there's 2 of them. So 6 times 2 is 12. 12 plus another 14 is 16. 4 plus 6 times 2 equals 16. So we have 16 electrons to work with. Carbon likes to be in the middle, like I said before. So we're doing step 2 now, we're drawing the symbols. And there's 2 oxygens, and we're going to make it kind of balanced, 1 on each side. The next step, step 3, is draw single lines connecting them. Step 4 says draw the remaining electron dots so everybody is happy. Well, if you look at the carbon here, carbon is not happy. Carbon has 2 over here and another 2 over here, so it has 4. Now it wants 8, just like all atoms. Their goal, the reason they form these molecules, the reason they bond with other atoms, is to get 8. So we need to make carbon happy. So now carbon is happy. 2, 4, 6, 8. It's happy. These oxygens are not happy. Oxygen has 2 here, so I'm going to add a couple more. Actually, more than a couple, 6 more. So now this oxygen has 2, 4, 6, 8. This oxygen also is not happy. But now it is, because I added the dots. So remember, step 4, you add dots to make everybody happy. Now the last thing you do is you check your number 16 with your picture. And if we count it up, you'll notice that it doesn't match up. If we count the number of electrons in this picture the way I have it drawn, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We've got too many. Now when you get that situation, what you do is you change your single bonds into a double bond. So this is going to become a double bond. Now when I do that, what that allows me to do is to erase. I don't have an eraser on this thing, at least I don't think I do. So I'm just going to scribble them out. What it allows you to do is to get rid of a pair of electrons on this side and a pair of electrons on this side. So imagine those scribbled out ones aren't there anymore. If we look, oxygen over here is still happy, 2, 4, 6, 8, because 2 lines like that equals 4 valence electrons. 1 line equals 2, so 2, 4, 6, 8, it's still happy. Carbon is still happy, 2, 4, 6, 8. Let's find a total here. 2, 4, 6, 8, 10, 12, 14, 16, 18. Well, we were at 20, now we're at 18. We're getting closer. So like I said, these things want to be symmetrical as much as possible. You could make this add up by putting a triple bond over on this double bond, but again, they want to be symmetrical. So the next thing I'm going to try here is I'm going to make this single bond over here into a double bond. And then what I'm going to do is I'm going to get rid of a pair over here and get rid of a pair over here. When you make a single bond into a double bond, you can erase a pair on each side of that double bond. So I'm just going to rewrite this just to make it a little less sloppy, even though my handwriting with this thing isn't very good to begin with. Oh shoot, I messed up. I can put it over here. So that is what carbon dioxide, CO2, looks like. Has a carbon in the middle, a double bond on each side, and each oxygen has 2 pairs of electrons on it. So let's count that up again. 2, 4, 6, 8, 10, 12, 14, 16. So it checks out with our number over here. We have 16. Always got to make sure everybody's happy. Oxygen has 2, 4, 6, 8. Remember, each line equals 2. This carbon has 2, 4, 6, 8. So it's happy. Same with the oxygen over here. 2, 4, 6, 8. So everybody's happy. We're running out of time on this video, so I'm going to quit here. The next video we'll pick up with the last few examples.